Okay, welcome back 8th graders. So I know you guys were waiting anxiously again for a video, and so here it is for this week. This week in this class, what we've been studying is something called irrational and rational numbers. And since we've been studying irrational and rational numbers, what you guys need to know is what the heck is a rational number in the first place. Like if you looked it up inside of an encyclopedia or dictionary, what would it say on Wikipedia? Well, a rational number can be written as a ratio. A ratio is a fraction, and you should be able to write that fraction with a numerator and denominator with two integers. Now some of you guys are like, what do you mean integers? Well, I mean whole numbers. So if you can't write it as a whole number, and here's what I'm talking about. If I went ahead and told you is 75 hundredths, is this a rational or irrational number? Well, this right here would be the tenths place, and this right here, this would be the hundredths place. And that means the way that you write this is you write this as 75, and you take the place that the last digit is in. This last number is in the hundredths place. So then you write that as 100. Since you can write this as 75 over 100, this is an integer. This is a whole number. This is an integer. This is a whole number. Because they're both integers, you could say that this is a rational number. Now, if you wanted to, you could reduce this and say, okay, the same fraction is 3/4. This is definitely a rational number because the number 3 is a whole number and the number 4 was a whole number, okay? They're both whole numbers, they're both integers. That means that this is a rational number. This is called a rational number. That means any number equal to this is also a rational number. Now, I want you guys to know that there's a lot of numbers that are not rational numbers. That means you cannot write them as two numbers. The numerator and the denominator are not whole numbers. Let me give you guys some examples of irrational numbers. So, irrational numbers are numbers that can't be written as whole numbers. Here's what I'm talking about. If you had an irrational number, like this is called pi. Not the kind of pie that you eat, the kind of mathematical pi. This pi is equal to 3.141592. The next number after this, there's no pattern. We cannot predict this next number. We can memorize it if we learned a lot of different numbers, but we don't know what the next number is. There's no pattern to this. So this is called an irrational number. Another example of this is if I took the square root of, 84. Now, we know that the square root of 81, this equals 9, which can be written as 9 over 1. This is called a rational number. This is a rational number because 9 and 1 are both whole numbers. But the square root of 84, it's not the same thing. See, this is going to be 9, 0.16. Now the next number you're thinking, okay, maybe it's another 16. It's actually 515. You're thinking, okay, maybe I know the next number. It's actually 139. And then it just keeps on going forever and forever. We cannot write this number like a fraction, like we can write the square root of 81. See, the square root of 81, the square root of 64, the square root of 49, the square root of 36, the square root of 25, all of these numbers, we can say, well, this is 9, which equals 9 over 1. This right here is 8, which equals 8 over 1. This right here is 7, which equals 7 over 1. We can write this as 6, which equals 6 over 1. And of course, this is 5, which equals 5 over 1. Since we can write all of these fractions as integers, whole numbers, these are all rational numbers. But let's say that I put the square root of something like 120, and I put it over the square root of 16. Well, the square root of 16 is 4. And you're thinking, well, isn't the square root of 121 equal to 11? Yeah, it is. But this isn't going to be equal to 11. This is equal to 10.9. And the next numbers are going to be 5, 4, and they're not going to be a pattern. This is going to be 4, 5 again. Then this is going to be 1, 1, 5, and there's no pattern here. See, because this number right here is a non-integer, we can't say that this is a rational number. This number here, this is irrational, even though the square root of 4 is rational. Because this number is not a whole number, this is an irrational number. So, here's what I want you guys to do. I want you guys to take the example that I just gave you, and I want you guys to go ahead and tell me whether the two numbers that I'm about to give you are irrational or rational. Let me go ahead and give you something like this. Let me give you the square root of, let's say, 54, and let's say the square root right here of 169. I want you to tell me which one is irrational and which one is rational. Hit the pause button right now and you decide. After you hit pause, go ahead and try to figure out which one of these is rational and which one is irrational, and then pause me back in and then check your answer. I'll wait. Okay, so hopefully you went ahead and decided. Well, here's the thing. The square root of 169 actually equals 13. This can be written as 13 over 1. So that means that this is actually your rational number. And this right here, since the square root of 64 is equal to 8, and the square root of 49 is equal to 7, this number is going to be in between 7 and 8. This is not going to be a whole number. This would have been your irrational number. Right there. And of course, this would have been rational like we explained before. So that's what we've been studying this week, rational and irrational numbers. Next week, we're going to start something new. We're going to start doing the slope of a line. I hope to see you guys next week. Bye.